Hi, hello, vanakkam, and welcome back to yet another episode on Little's Law YouTube channel. So, today we're going to take a little break from our network performance testing videos. And if you really want to watch that videos, please check out the link in the comment section. And today, this is going to be the second video on database performance improvement because this is again a most important concept that is being discussed in all the interviews because you might be getting a lot of questions back to back regarding the database performances, and the interviewer might ask you a lot of questions one after the other asking for the best practices that you do to tune the application. And here, initially we discussed about the indexing. So that's a very basic thing that has to be done for improving the database performance. So the next point is this one that we are going to discuss today. So today we are going to discuss about the efficiency of the queries. So when the interviewer asks you like what is your first tuning suggestion, and we will tell about the indexing that we discussed in the previous video, and after that he might ask you, okay, so by default the indexing has been done, and what will be your next choice of tuning? So when this question is asked, so here you will have to jump to the efficient and inefficient querying. So first let me explain you what is an efficient searching and an inefficient searching, and I will just correlate it later to an efficient and inefficient query, and then I will take you through the impact of this efficient and inefficient querying, and then finally I will take you through the what and how the tools of finding the same during your performance testing, and then I will tell you some of the best practices of the efficient and inefficient querying. So before that, this is me, your Vasant Shanmugam. I welcome you all to Little Slaw YouTube channel. Please don't forget to subscribe to our channel if you have not subscribed yet. Like, comment, and share your questions in the comment section. So first, when we see about the efficient and inefficient querying, I will just give you an example. So there is a magic man in the town, and he has a magic box filled with toys, and he wants to find his favorite toy car from the box. And there are many toys in the box, which includes cars, which includes dolls, blocks, and stuffed animals. So to find his toy car, he has two ways of searching. So the first way is the efficient searching. So through this efficient searching, he knows exactly what his favorite toy car looks like. So he reach into the box, he feel around for the car shape, and quickly pulls out the toy car he wanted. And this search is fast and easy because he only looked for what he needed. And that is called as efficient searching. So when it comes to the inefficient searching, in the second method of inefficient searching, he decided to pull out everything from the magic box one by one and examine each toy to see if it is his favorite toy car. And he end up spending a lot of time looking at the toys that he really do not want, like dolls, the blocks, and in fact that action has actually slowed him down. So now when I'm relating this to computers and mainly with the databases, what happens is, so when it comes to an efficient querying, so the efficient query is like the efficient searching that he did earlier, that is finding that toy car. So it asks for the database for only the information it needs, and the database quickly gives back the exact information, just like how he quickly found his toy car. It is fast, it saves time. And when it comes to inefficient querying, sometimes a computer program sends an inefficient query, just like the inefficient searching he did. It asks the database for too much information, even it thinks it does not need. The database has to work extra hard to find and give back all that extra information, just like he had to spend more time looking at toys that he did not really want. So now I will take you through the example. So here, when it comes to examples, here you can see the efficient query. This is a well designed and efficient query that looked like this. In fact, in this query, the database is instructed to find only the, or he has to retrieve only the product name, the price, and the stock quantity for the products which are belonging to the electronics category with a positive stock quantity. The result set will be very concise and include only the relevant data, making the query fast and responsive. On the other hand, let me give you another example of the inefficient query, because when the user or when the developer or the database administrator creates this query, so what happens here is the database is instructed to retrieve all the columns from the products table, and this means that it will fetch not only the product name, its price, and the stock quantity, but it also extracts all the other data like product descriptions, its images, and any other fields in the products table which is not actually required at this situation. And additionally, it retrieves data for all products which are regardless of their category or their stock quantity. So what is the impact? So why in turn what does it have bring in? Like I write efficient queries and both inefficient queries. So how is it going to impact the user? So the very first impact of this inefficient querying and performance testing, or like performance of the application, is the slower response times, because the inefficient query, so in the example we saw, the inefficient query retrieves a large amount of unnecessary data, and it takes more time for the database to process the request and return the result, and as a result the website will load more slowly for users, leading to frustration and a poor experience. And then when it comes to the second example, which is the increased database load, so this inefficient querying places a higher load on the database server, and it needs to process and transmit large result sets. And this increased load can lead to degraded performance for other queries as well, which are in the database. And the processes running on the databases will affect the overall website performance. And then coming to the third impact, which is excessive resource consumption. So the unnecessary data fetched by the inefficient query consumes additional server resources such as memory. It in fact it takes a lot of network bandwidth since it sends a lot of data, and in fact it creates a crunch. It in fact takes a lot of space in the network. So this could lead to resource exhaustion, and in extreme cases, even it can crash the server or it can slow down the server. And then the fourth impact is the scalability issues. So as the website traffic grows and grows and the database size increases, inefficient queries become even more problematic. So this issue in most of our applications, the developers or the users might not face this issue, the performance issue, during the initial stages of the applications, because in the initial stages the database size will be very less and the database can handle any inefficient queries. But going forward, when the database starts to grow, automatically this inefficient query might be a problem, because it will increase the database, the website traffic. So this the system might struggle to handle the growing workload, which results in more performance issues. And then when it comes to the last impact, which is the increased cost, so the inefficient querying leads to higher resource consumption, which can result in increased infrastructure cost to support the website's performance requirements. So these are the major impacts when it comes to the inefficient queries. So now let me take you to the tools of how to, or where we can identify the bottlenecks, the database bottlenecks exactly. So the first tool that we normally use to find the database issue is the load runners virtual user generator, or the VueGen. So where we use this tool, which we can use to record and create performance test scripts. And when we create a script, so the VueGen captures the interactions between the virtual user and the application, including the database queries. And we can then review the script to inspect the captured queries and their performance. And next comes the tool which is JMeter, which is a commonly used tool. So JMeter is an open source performance testing tool that allows us to create scripts to simulate user behavior, and it also provides options to capture and log the queries executed during the test. And using that, we can analyze the JMeter test logs to identify the queries and their performance characteristics. And then the third option is we can use the database monitoring tools. So some performance testing tools and APMs, we normally call it as application performance monitoring tools, offer database monitoring features. And we all know, we all have used that. So when we keep on drilling down the queries, at one point of time, we will get the most expensive query or the query that has been executed most number of times. So these tools can capture and analyze the SQL queries which are executed by the application during the performance test. And some of the examples of APM tools, which includes New Relic or App Dynamics and Dynatrace. So in one of our videos, very soon we will try to see how this tool, the APM tools work. So it can be either App Dynamics or it can be anytime it can be Dynatrace. So we will meet with an interesting video very soon. So next option is the database profilers. So again, database profilers are very powerful tools when it comes to this kind of finding the inefficient and efficient queries. So database profiling tools such as the Microsoft SQL Server Profiler or the Oracle SQL Developer, they can be used to monitor and capture the database activity during performance testing. And these tools provide detailed insights into the queries executed, their execution times, and the resource usage. And then next comes the query logging and profiling features. So some databases have these inbuilt query logging and profiling features. So by enabling query login, it allows us to capture the SQL queries which are executed against the database during the performance test. And by reviewing the query logs, we can analyze the queries, their performance, and their bottlenecks, so we can identify all of them. So as I told you, so these query logging and profiling tools are more powerful and they can be used to, and like they are like some of the inbuilt tool inside the databases, and they're very powerful since they can query the logging to capture the SQL queries. And then when it comes to the last option, which is the database monitoring script, so in some cases, performance testers can write custom scripts or use existing monitoring scripts to capture and log database queries during the test. So these scripts can be instrumented within the application code, or they can be even run as separate monitoring agents. So regardless of the tool or the method which are used, so the goal is to capture and analyze the queries executed during the performance test. And by identifying slow or inefficient queries, we can work with developers or the database administrators to optimize the database schema. We can create appropriate indexes, or we can rewrite queries to improve the overall system performance. And again, performance testing should closely simulate real world scenarios and user behavior to get accurate and relevant query performance data. And by analyzing queries and database performance, it's an essential aspect of performance testing to ensure the application performs well under load. So before I end the video, I will take you through the most critical, and this is what you are supposed to answer to your interviewer. So he might ask you what are the tuning suggestions you will give to the developer or to the database administrator, and you will have to give him at least 10 to 11 options so that he might be get satisfied, and there are high chances where you might be getting selected at the end of your interview. So you have to be very wisely. You'll have to answer with multiple choices, because the interviewer might tell you, no, this option is fixed or this option is not possible. So what are the other options that you might bring to the table? So at those situations, you will have to have at least these many options. So these are some of the minimum, at least some 11 options which I'm going to discuss with you today, and you'll have to give these options, and you'll have to explain it to him, to the interviewer, that I will use these techniques, I will use this way, so that the performance can be improved. So the very first option is using the indexes wisely. So indexes, as we all know, are like a table of contents to the database and helping the database to quickly find the data that we need. So making sure that by creating indexes on columns frequently used in where classes and join conditions. But on the other hand, we should not have, or we should avoid over indexing, as too many indexes can slow down insert, update, and delete operations. And then the second tuning suggestion, so that interviewer might tell you, okay, so I have indexes ready. Uh, I have efficient indexes. I do not have over indexes. So what else the next option is? So the next option is the most critical option, which is again minimizing the select star statement. So by avoiding the select star, we can avoid fetching all the columns from the table, and instead by explicitly specifying only the columns that we need, because by fetching unnecessary data can put extra burden on the database, on the network, on the application, and they all might lead to slower the query execution. And then when it comes to the third option, which is optimizing the joins, so by using inner join whenever it is possible, as it's generally faster than any other types of joins, so we'll have to ensure that the join columns are indexed for better performance. Also, we have to consider denormalizing data, or we'll have to use materialized views to reduce the need for complex joins. So anytime whenever you get a chance, we will have to go and explore what are all the joins that are used in the queries, because there are chances where the developer might use a left join or right join or an outer join. So just another tuning suggestion. So this inner joins has to be used whenever it is possible, at as it is generally a way to improve the performance. And then next comes the limiting of data retrieval. So by using the limit or top class to retrieve only a specific number of rows if we don't need all the results, and this can significantly reduce the query execution time, where especially when dealing with large data sets. And next, when it comes with avoiding using sub queries, so subqueries can be slow, especially when executed multiple times. Whenever possible, we'll have to try to rewrite these subqueries as joins, and especially if it comes to joins, it has to be, yes, in a join. Or we'll have to use temporary tables or common table expressions to improve the performance. And next comes the parameterizing of queries. So what is parameterizing of queries? And so by using this parameterization of queries or prepared statements instead of dynamically constructing SQL strings, so the parameterization prevents the SQL injection attacks, and it can improve the query plan reuse, and this can lead to better performance. And next comes the analyzing query execution plans. So by reviewing and analyzing query execution plans, we can identify the potential performance bottlenecks, and making use of database query optimization tools and features to optimize the execution plan. So that is a critical one in when it comes to the performance of application. And next we have is the monitoring and optimizing the database configuration. So regularly monitoring the database performance and optimizing its configuration settings. We can also adjust the memory allocation, its buffer pool sizes, and other parameters which are based on the database workload and available resources. And when it comes to the ninth tuning suggestion, so by frequently caching the used data. So when we are considering implementing the caching mechanism to store the frequently accessed data in memory, so this can reduce the need to query the database repeatedly for the same data, improving the response time. So the cache, on the other hand, when it comes to database, yes, it can improve the performance when it comes to querying the frequently used data. And then when it comes to the 10th point, which is normalizing our database, so we'll have to organize our database into normalized tables to avoid data duplication, and in turn it can improve the queries efficiently. And by properly designing database schemas, which can result in more efficient data retrieval. So these normalizing, we all know it's again a big, very big topic, so we will have to normalize, or the database administrators has to normalize the tables whenever he gets time. And then when it comes to the 11th option, which is regular updation of statistics. So by updating the database statistics, it can help the query optimizer to make better decisions when executing queries, and this ensures the most efficient execution plan is chosen for each query. And then the last tuning suggestion, that is used stored procedures. So by encapsulating frequently executed queries within stored procedures, these stored procedures are pre-compiled and can improve query performance. It can reduce network traffic and enhance security. So by following these best practices and tuning suggestions, we can optimize our database queries. We can reduce query execution times. We can enhance the overall performance of our application. And by regularly monitoring query performance and by conducting load testing to ensure the database performs optimally as our application grows and evolves. So when you answer most of these tuning suggestions, there are 99% of chances where you might get selected, because these many suggestions, for sure the interviewer will be very shocked and surprised to know that you have these many suggestions. And you, if you really keep on working on these suggestions, on these tunings, you will definitely have a better chance of clearing an interview, and even you can improve the performance of the application. With that, I come to an end. I believe this video would have been very useful to you. Until I meet you in another interesting video, it's bye bye from Ascension Mugam and Little's Law.